Hi, everyone. I guess we can begin. Can you hear me? I think you can. Yeah, my name is Alina. I'm very happy to be back here. I love DevOps Belgium, and I specifically love those tools in action sessions where you have little time, so minimal slides, minimal chit-chatting, straight to the code. So thank you for coming. And in this session today, we will talk about GraalVM, native image, and all the things you need to know about it to use it in production. So how do you build applications? How do you use libraries? How do you monitor them? Everything you might want to know for using native image. So let's go. And with that, I will sit down if that's OK with you. I could have said that this is for coding, but honestly, I would just be a bit more comfortable. So let's go. And this is our little plan for today. Let me just close others. And close this. OK, good. So this is a session about GraalVM and about native image specifically. And I hope that at this point, I don't need to talk anymore about GraalVM and what it is and what it can do for you, but just a super quick 30-second recap. So GraalVM is a JDK like any other JDK of your choice. If you're not really taking anything away from the JDK, we are just adding things on top. So one thing we have added is the GraalVM JIT compiler, and it's a very good, highly optimizing compiler, and an alternative to C2. And many applications will see performance benefits somewhere around 10, 15% from just moving to Graal as a JIT compiler just by using GraalVM as your JDK distribution. Now, another part that we have added to JDK is an ability to execute other languages, those that are not traditionally JVM languages, on top of the JVM and within Java applications. So one thing you can do with GraalVM is you can extend your Java application with languages such as JavaScript, Python, WebAssembly. And what's even better now, we improved the developer experience. So all you need to do to bring those languages to your Java application is just bring in 2 Maven dependencies, and you're good to go. But that is a story for another time. Today, we are talking about all things native image. And native image is this ahead-of-time capability in GraalVM, where we can take your application and compile it ahead of time into a native executable. And the reason to do so is because you will no longer need a JVM once you deploy that application. It will be fully functional on its own. And the reason to do so would be because we will eliminate many of the startup and resources usage potential challenges that you can have with a larger Java application. So because we are optimizing and compiling your application ahead of time, we are doing that work once, and then you can start fast every single time. So this is the startup because you compile the application ahead of time, but there are also other benefits and ones that I would argue are more important than startup. One of such benefits is memory usage. So if you want to run your application using less memory, on average about, I would say, 3x, 5x less than on the JVM, native image can do it for you because we no longer need to load classes, interpret, compile, etc. So that's one benefit, startup, memory usage. Also, you will get much more compact images. And also, native image gives you an additional security layer because there are way less dynamic features, or they are restricted and only allowed by the allowed list. And also, native image eliminates all the code that you are not using. So the idea is to compile the application once and then deploy it fast as many times as you would need. So that was a very brief intro. Let's see it in action. I want to start with this first demo, which is a dictionary application. And I will run it first, and then we will compile it. And as it compiles, we will see what it actually does. So I mentioned that GraalVM is a normal Java, right? So I can check it with my Java version. And here I'm on Oracle GraalVM for JDK 23. So this is the latest release version of GraalVM, released up to date. A couple of weeks ago, we released this along with Java 23. So this is the latest version at the moment. What's interesting, on Thursday, I have another session, and there I will be using GraalVM for JDK 24, so unreleased version, early access build. But at the moment, this is the latest production-grade build of GraalVM. So let's run our app, and let's see what it does and what are the fun things we can do with it. So as you could have guessed by now, we will be looking at a Spring application here. And it starts in something like 2.7, I would say almost 3 seconds. So let's go to our endpoint. This is at localhost, and the endpoint is translations. And I'm wondering if somebody in the room can tell me what is this beautiful language. You can guess. Not German, not exactly. Swiss German, yes. So if you, like me, like languages, or if you speak High German, I encourage you to look into Swiss German. As you can see, it's very interesting. My favorite word might be Büssi, which is cat, or rather kitten. And another fun word is Bitly, which is floating down river on inflatable boards and drinking beers. So a very fun language. I encourage you to check it out. But our application starts and runs, but where is the fun in that? Let's make it native. So let's go ahead, and my compilation command for this, as it's a Spring application, is maven pnative compile. And now we will use the compilation time to take a look at our application and what is going on there. So as you've seen already, this is a Spring app. This is my main class. And I have a bunch of things here. So this is my controller that exposes the endpoint, gets us back our translations. I have translation service that interacts with it. And I have translation repository. And then the actual data is being here. So this is our data, and this is using under the hood H2. So we are reading our translations from the database. And in terms of the project structure, here is my POM XML. Let me just remove this. So what we have here is our Spring Boot. In terms of dependencies, we have our Spring Web. We have dependencies for working with data. In our case, it's H2. And the part that is interesting for me is native Maven plugin. So this is the part that is responsible for native compilation. And this plugin, as you can tell, is coming from our team. So if you go to start.spring.io and you add GraalVM native image as a dependency, what the Spring team will do for you, they will include this plugin, but the plugin is originally developed by our team. And this is a very nice kind of unified interface for working with native image. So from here, you can configure all the things you would like to do with your app. For example, here I'm doing -OB. This is a quick build mode. So I'm saying, hey, I'm not deploying my application yet. I'm just still developing it. So please give me my build back fast so I can iterate faster, but this will not optimize for production because we are not deploying to production yet. So I'm just saying I want faster feedback loops, but I don't care about optimization at this phase yet. So this is one way to do it. And normally when I'm compiling this application and I'm showing something like this on the stage, people come to me and they say, Alina, oh my God, this is taking so long. I don't have that kind of time. Why does this application build has to be this long? But check this out. So my application was maybe 5 classes and let's say database, but still. And what native image discovered about it is, as we are looking at this analysis phase, underneath, so coming from the JDK, from my framework, from my dependencies, what native image found is reachable is 200,000 classes, even in this fairly trivial app, because as we know, Java projects give us good productivity, give us a lot of amazing features, but it comes at a cost that underneath there is a lot of complexity in our projects. So I would say that this compilation time, how long was it? 1 minute, 40 seconds for this complete web app with a database access. I would say this is still acceptable. But let's go ahead and run it. So target demo. And yeah, what I actually need is this demo native executable. And I have some additional files generated for me courtesy of AWT. But what I need is actually this demo application. So if we go back here and we hit our endpoint again, it does the same thing. Here are my translations. So as it runs, we can also do a quick, not even benchmarking, but try to assess how many resources it's using. For that, I will do htop, and I will look for my application. So granted, it's idle, but we will do load testing later on in the talk. So in this idle state, it's using 136 megs of RAM, which I would say it's not too bad. For a fully blown web Spring application. And why I'm talking about this is because I think along with startup memory usage is indeed important because you can deploy, as I like how Josh Long and James Ward talked about this here at Davos 2 years ago. So imagine that for application that uses 100 RAM of memory as a native executable, you can maybe deploy 10 such applications for the same footprint that you will deploy your normal big Java application with large heap settings. So I think those memory savings are a really important aspect of native image, maybe even more important than startup time. So OK, let's say we moved our application to native. It was fairly easy. In my case, how this application came to be is just I went to start.spring.io, I added all my dependencies, and it worked. And in general, it will be the case that if you're starting a new app and you're working with one of the frameworks that work with native image, so Spring, Micronaut, Quarkus, Helidon, if you're starting a new app, things will be fairly easy for you. Now, what to do if you want to move an existing application to native image? And I don't want this to be a sales talk, so I will not say that every single application will work like a charm out of the box. If you want to move an existing application, there could be some challenges. If you want to learn more about those challenges, Daniel and I are doing a session on Wednesday, but I want to very briefly walk you through it in case you cannot make it to our session. So what could be a source of challenges, and how do you use libraries in the native image mode? The source of challenges, there could be reflection and those more dynamic Java features, such as serialization, resources, proxies, JNI, etc. And the reason why this might be challenging for native image is because native image compiles the application ahead of time under a closed world assumption. And this means that runtime hasn't happened yet, so everything there is to know about your application needs to be known when you build it. And this isn't a limitation of native image as much as it is a limitation of general AUT versus JIT. So you're compiling things ahead of time, they need to be known. Now, native image can do pretty much anything for you as long as you tell it what exactly needs to be known and happening at build time. So how do you make reflection work, and how do you make all those dynamic Java features work with native image? I will go here through some of the possible scenarios. I will try to be brief. Let's see if that works out. But I will go here through some of those scenarios, how libraries can work with native image. And each of those bullet points, it's a complete answer to making a library work with native image, going from the best case scenario to a maybe less fortunate scenario. So one is native image, and libraries can be friendly towards native image out of the box. So this is a new trend, but we see more of this lately, especially on social media, where maintainers write libraries, and they write them in a way that is more friendly towards native image, so maybe using less reflection, doing more of like functional style programming. So those will just work out of the box with native image. But also, we realized that there were many libraries out there long before GraalVM and native image came to be. So how can those libraries that existed before work with native image? And as I mentioned, native image can do anything for you as long as you give it configuration files to instruct it what exactly needs to happen in terms of, for example, reflection. Those config files come in the format of JSON, so you need to instruct native image, please make those things visible and build an application that is aware of those classes being accessed reflectively. So how can that config come to be? The next best scenario is if a library that you want to use includes config for native image within the library itself. What I like about the application that I showed before, the dictionary using H2, is that in the past, I was showing a demo where I was trying to read and write data from the H2 database, and it was compiling successfully, but then it was blowing up at runtime because it could not figure out how to work with reflection. Now, that is not the case anymore. Things just work now because H2 itself ships with config within the H2 library itself, and on top of that, we also have our own config for H2. So if your library doesn't include configuration for native image, the next best thing that can happen, you would think that there can exist something similar like Maven Central, but for native image configuration. And we had the exact same idea, and now we have this repository on GitHub called GraalVM Reachability Metadata Repository, which is a long list of folders for many popular libraries and frameworks that includes config for all those libraries and their versions. And the way to consume this is really automatic, because if you are using our native Maven or Gradle plugins, the ones that I showed you before, they will just go and pull config from this centralized place for you without you having to do anything. So if you're using a more or less mainstream Java library, chances are that things will just work for you out of the box. But let's say you want to use a library that doesn't have config for native image, maybe they haven't added the config yet, or maybe your company has some internal library, SDK, that is not compatible with native image, so what to do in that case? Now, there could be a few solutions to that. One is if, like in my other demo, if you are on a version of a framework that is compatible with native image and offers some features for native image, such as, for example, here I am on Spring Boot 3.4, but anything above Spring Boot 3.0 and higher would work. So what you can do is you can generate hints programmatically. So you can instruct Spring to generate hints for those places in your application where reflection will occur, and Spring will solve this for you. So let's see this in action. And for that, I have this app. And here I have my little reflection controller. So one thing that I want to mention here is you can say that I'm trying to make a reflective call to this message field in a message class over here. but I'm doing so, as you can tell, in a less maybe predictable way, or maybe not in the way you would write it, and that is to try an Outsmart native image, because a more predictable, more reasonable, more sane reflection call, native image can figure out of the box. It does have limited but support for reflection out of the box. That's why we are trying to go ahead and Outsmart native image here. So to make this work and to make this visible for native image, what I can do, because I have support for Spring from Spring for me, I can do register reflection for binding, and I have my import added. So now I can say, hey, my reflection will occur here in the message class. Please generate hints for me. And I didn't build it before to try and save us 40 seconds of time, but let's go ahead and build this now and see if this will work. So this is Spring Boot, and we are again doing native compile. OK, so our build has started. As it started, I want to show you two more things related to reflection and how you can programmatically generate config files for native image. So this is one way to do it, and this is the one that existed for a while in Spring. Now, in the upcoming release, they are also introducing a new way. So here I'm handling reflection and writing the annotation on the caller side, so where my reflection call originates. But they're also experimenting with a new way where you can annotate my callee side, so where the reflection call needs to end up. And I can say here reflective and add reflective scan on my main method, and this will make this class or field visible in terms of reflection to all the possible places in my app that might call this method or this field. So you can decide for yourself, either you want to do it where your call originates or where it's supposed to end up. Now, this is not even the complete story yet, so Spring offers you yet another way to make reflection or resources or serialization work, and they have this nice runtime hints registrar API, where I can say, hey, I want to access this resource at runtime, please make it available to native image, please generate hints for resources, and this is a nice flexible API, because along with resources, I can do something like hints.reflection or reflection or GNI, and it will also generate hints for those things. So those are three possible ways to do so from Spring, but also similar exist in other frameworks when they can help generate files for native image. Now that our build is complete, let's go ahead and run it. So target demo. And our endpoint that is responsible for reflection is this one. So we retrieved our message. And in a similar fashion, we can do resource, and we see that we can also load the resource. So this was about making reflection and other dynamic Java features work for your application from a framework. To finish this part, so you can generate hints from your framework if you have framework support. Now, let's say you want to use a library, but you are on a version of a framework that doesn't work with GraalVM. The library doesn't have config. Seems like you're out of luck and out of options. Well, not just yet. So if you don't have any support from your library on framework, there is one more thing that you can do, and that is you can use this tracing agent from native image. So this is an agent that comes with native image, where you can run your application on the JVM with the agent attached to the process, and you can show the application what it's supposed to be doing, apply relevant workload, and then the agent will observe your application behavior, in particular all those things around reflection, and will output configuration files that can native image pick up and automatically resolve those calls for you. So the agent will generate those files for you in a semi-automatic way. It will not always be complete, maybe, or maybe you need to apply really good workloads, but this is a good way to do these JSON writings in a semi-automatic way rather than writing the files yourself. And then the last is, if you have this one small call that just doesn't work with native image, but you know exactly where it appears, you can do so yourself manually. You can just write this configuration file yourself from a JSON format. So this was maybe a bit too complicated and a lot of text, but really, if you want to make libraries work with GraalVM native image, this is the things you need to do. And I hope, especially if you're starting a new application, that you never need to go beyond those 3 points, that either a library will ship a config or it will be available in our centralized repository, especially for new applications. So we were talking about writing applications and using the libraries. Now let's talk about another thing, and that is how you can optimize your native executables with native image. So there are many optimization levels in native image that you can choose from, and I feel like this is like less known. So maybe if you want, you can take a photo and you can look into this after. But basically, you can set those flags to set your preferable optimization level in native image. So the -0 is usually used for debugging purposes. This is no optimizations at all. Then 1 through 3, this is optimization levels going from basic optimizations through advanced to full optimizations. Here I need to mention that -03 is available in Oracle GraalVM. Now, -OB optimizes for build time. This is what I was using in our dictionary application. And then -OS optimizes for size. Now, for me, this is not the most common concern, like the size of my native executable, but people in our community told us many times that they want to have something like this. And in my measurements, again, I tried it on a Spring Boot application. It shaves off around 1/3 of your application size. So if you want to maybe have smaller binaries, -OS would be the way to go. Now, if you want to optimize for the best peak throughput, and I hear this comment a lot about AUT and JIT and how native image would now be as fast as JIT because JIT optimizes your application on the go. Now, in general, it's an interesting theoretical discussion whether or not AUT code can be as fast as JIT. If you are curious, we can chat about it during the break. I will be very happy to do so. But here are optimization strategies that you can use for the best peak throughput. So one thing that you definitely need PGO. This is the flag that triggers our profile-guided optimizations. And the way this works is that you can build an instrumented version of your native executable, apply relevant workloads, observe your application behavior, and then after you shut down your application, it will produce profiles file that you can then feed or rather automatically pick up when you build your native image for production. And this way, we have access to what your application will do at runtime, and specifically which parts of your application would be more hot. Now, here people often tell me, but the JVM profile is on the go. It always adapts to what your application is doing. That is true, but what is also true is that a lot of profiling the JVM does during startup, and then it still observes and profiles your application, but many of those key assumptions are made during the startup. While native image, even though it doesn't have access to the runtime information of your app, it instead has access to this closed world of your application where everything there is to know about your app is already known. So I would say that native image does a different kind of profiling, but it also can give you good peak throughput. In terms of other performance optimizations, one more thing that I can recommend is using G1 GC for peak throughput, especially if you have an application that is long-running, does a lot of allocation, uses a lot of threads, then G1 probably will be your best shot. One new GC thing that we introduced in the last release is now we have this new compacting policy for the serial GC, which is less tailored towards peak throughput, but it's rather targeting making sure that you will never go overboard with peak memory usage. So if you want to have good peak throughput, but you want to make sure that you will never go overboard with memory usage, use this compacting GC policy. And then the last flag here is MARC native. So this says, hey, I'm using this machine, and I will be building and deploying on this machine. So please specialize for the specific architecture and hardware features of this machine, as opposed to building a binary that will be very compatible with many possible versions of the same architecture. So this will specialize for the machine that you are building on. Now, I was debating whether we have enough time for benchmarking, and we don't have enough time for proper benchmarking, but I know that otherwise you wouldn't believe me about all those flags. So let's see if we can do at least quick round of benchmarking. For this, we will run our same dictionary application, only we need to go back to the dictionary folder. So what I will do here, I will run my application 3 times. First, I will run it on C2. So this is in the JVM mode with the C2 compiler, same compiler as in your, let's say, OpenJDK. And the script will start my application, the same dictionary app, and then we will use the benchmarking tool called Hey to send 500,000 requests to our app. In the beginning, we will also wait 5 seconds to give the JVM a bit of time to start. So if we run our application, our peak throughput is around 50K requests per second. Let's get a native version, only let's do the comparison side by side. So now I will send the exact same load, and I will also wait like I had to wait with the JVM, but we will again save 500,000 to our application, now just the native version. So here we were at 50K requests per second. Who thinks that the native version will be faster? Well, you know that I work on GraalVM, so I could have applied some weird tricks to kind of seem faster, right? But let's see. So this one is at 42, a bit slower than the JVM, but this was our native image out of the box. So this is the experience you will get if you are not applying any optimization yourself. Now, what happens if I go ahead and I apply those 3 flags that I mentioned? So bench, native, optimized. And this is a version with PGO, with G1GC, and MARC native. And let me just push those side by side so we can compare when we get the final numbers. OK, so 50K, 42K. And once again, disclaimer, by no means this is scientific benchmarking. Scientific benchmarking will require at least like half an hour and a proper isolated machine, but close enough for a conference session. So 50K, 42K, and here with the optimization, we are at 58K. So I'm not necessarily claiming that a native app will always be faster than the JVM, but what I rather want to show here is that the impact of those 3 optimizations, if you take the time and effort to apply them, can be substantial. So if you want to have good peak throughput on native image, test, and we can play with the combination of the flags, but most likely PGO, G1, and MARC native is what you want. Now, talking about the features that you might want to use in production working with native image, let me go back to my agenda. Here it is. So I want to very briefly say a few things about development strategies and then building and deploying. So for development, what I want to recommend to you is you keep developing on the JVM, and then you compile to native once in a while, maybe in your CI/CD, or once a day, or if you are touching things that you know are sensitive to native image. So if you're introducing a new dependency, if you are touching your reflection serialization resources, but you don't need to recompile every 5 minutes, or if I'm introducing minor changes to my business logic, this is just not necessary. It will be a waste of your time. A good practice is develop on the JVM and then compile to native, as I mentioned, in CI/CD, maybe once a day, or before the deployment when you're ready to deploy, or if you touch something major in your app, such as introduced a new dependency. Now, for building and deploying, native image produces native executables that are specific to a platform and operating system, because we need some JDK classes that are specific for each platform. Now, there are multiple ways around it. You can do container images. You can use something like build packs for that. Or another thing you can do is you can use CI/CD systems, such as, for example, I'm using for my demo projects GitHub Actions. And there you can just set up builds for each platform, and you can just build there and deliver to whatever platforms you need to deliver. So this will be my tips for that. Now, I want to show you one last thing for security and monitoring. And for that, let me switch to my local machine, because I need my UI here. So let's say, oh, by the way, did you know that you can do this? Well, it would have been installed, but in my case, it's because I already have it. Oh, wrong, Visual VM. So you can install Visual VM with SDK man, and you can manage along with your JDKs. I think this is pretty cool. So I have my Visual VM. Let's get it started. And I want to show you a version of an application that you can actually monitor in Visual VM. So I have the same app, or rather very similar, that I was showing to you before. And let me cancel. Let me just run this. Where are we? OK, demo central, native Spring Boot SBOM, and I need my executable. So this is, again, a native Spring application that runs. And when we go here, it returns hello. But more importantly, it's integrated with Spring Actuator. And what I can do here is I can instruct Spring Boot to pick up my SBOM file from a known location in the file. And this way, I can expose my SBOM, or I can take it from here and feed into my vulnerability scanners, and I can see what is actually in my native binary. So this existed before, but previously this was always embedded in the native executable. Now you can also include it as a class-path resource, and then it can be picked up from things like Spring Actuator. And I have exactly 1 minute, so I also want to show you how you can monitor such applications, because I hear a lot that there is no way to monitor native image applications, but that is not true. So I have built my application with a few flags. One of them is enable monitoring equals JVM stat, and this makes it possible for me to have my application running and being observed here in Visual VM. To prove to you that this is actually running live, we can go ahead and super quickly send a bit of load to my app. Hello, this is my endpoint. So I can go here, and I can send, I don't know, hey, and equals, let's say, 1,000 to my app. And it already responded because it was that fast. And here in Visual VM, I can see a bit of spike in terms of threads and something going on with memory. So this is one way to monitor native image applications, but also if you're deploying your applications to the cloud, many vendors offer some kind of support on that platform, so you can check out what they offer for native executables specifically. Now, with that, I want to wrap up. Here are my final few slides. So if you have any questions, I'll be here during the break and the rest of the week, or you can also get my demos from GitHub. And if you would be so nice, please rate the session. And I'm staying here to answer questions. Also, if you want to get stickers, I have some GraalVM stickers with me. Thank you so much for coming, and have a great DevOps. Thank you.